Installing non-metallic cable, often called Romex, in residential construction follows established industry practices passed down through experienced electricians. While not explicitly detailed in the National Electrical Code, these methods aim to ensure safety and prevent damage. One practice involves centering the wire between the strapping. This positioning safeguards the cable from potential punctures caused by screws or nails driven through the strapping into the joists. Another crucial aspect is maintaining a minimum distance of 1 and 1/8 inches from the edge of the strapping. This precaution prevents accidental cuts to the wire if the strapping is inadvertently damaged. Stapling the wire along the bottom edge of the joist offers further protection by keeping it out of the way of foot traffic, storage, or other activities that may occur in attics or basement. Running the wire parallel to the strapping and avoiding areas prone to foot traffic minimizes the risk of damage during insulation installation. While these are common guidelines, specific situations may require adjustments. For instance, limited space might necessitate running the wire closer to the edge of the strapping. In such instances, extra care should be taken to shield the wire from harm. The National Electrical Code does contain requirements related to installing non-metallic cable. Non-metallic cables must be secured with straps or staples at intervals not exceeding 4 and 1/2 feet according to NEC section 334.30. This securing prevents sagging and ensures the cable remains properly positioned. The code also mandates that non-metallic cables be protected from physical damage as detailed in NEC section 300.4. This protection encompasses safeguarding the cable from other trades working on the project and from potential harm during construction activities. The code also requires that non-metallic cables must be supported so that the weight of the cable is not supported by the conductor insulation found in NEC section 334.30. The reason the code has these regulations are firstly, electrical safety is paramount. Proper installation techniques minimize the risk of electrical shock, fire hazards, and other dangerous situations. Secondly, preventing damage. A cable is protected from physical damage, ensuring its longevity and reliable performance. Thirdly, code compliance. Adhering to the NEC and industry best practices ensures installations meet regulatory requirements. Fourthly, best practices promote efficient and reliable electrical systems. By following these guidelines, electricians contribute to the safety and functionality of residential electrical systems. The National Electrical Code provides comprehensive guidelines for electrical installations, but understanding the reasoning behind common practices enhances safety and promotes quality work. For example, consider the ampacity of non-metallic cable. The ampacity of conductors in non-metallic cables must be determined in accordance with NEC section 310.15. This section details the allowable ampacities for conductors based on factors such as conductor size, insulation type, and ambient temperature. The NEC provides tables that list ampacities for various conductor types and sizes. Understanding how to determine ampacity ensures that conductors are not overloaded, preventing overheating and potential fire hazards. Overcurrent protection is also essential for non-metallic cable circuits. Overcurrent protection devices, such as circuit breakers and fuses, protect conductors from excessive current flow. The size of the overcurrent protection device must be appropriate for the ampacity of the conductors being protected. NEC section 240.4 provides guidance on selecting the correct overcurrent protection for conductors. Using the proper overcurrent protection ensures that circuits are protected from overloads and short circuits. Grounding is another critical aspect of electrical safety in residential wiring. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and energizing the circuit. Non-metallic cable installations must be grounded in accordance with NEC Article 250. This article details the requirements for grounding electrodes, grounding conductors, and equipment grounding. Proper grounding ensures that electrical equipment and appliances are safely grounded, minimizing the risk of electric shock. When installing non-metallic cable, it's important to pay attention to box fill calculations. The electrical boxes must be sized appropriately to accommodate the number of conductors, devices, and equipment contained within them. NEC Section 314.16 provides guidance on calculating box fill. Overfilling electrical boxes can lead to overcrowding, overheating, and potential damage to conductors and devices. Using the correct size electrical box ensures that conductors and devices are properly installed and ventilated. Cable routing is another important consideration when installing non-metallic cable. Cable should be routed in a neat and orderly manner, avoiding sharp bends, kinks, and excessive tension. Cable should be supported at intervals not exceeding 4 and 1/2 feet, as required by NEC Section 334.30. Proper cable routing protects cables from physical damage and ensures that they remain securely in place. When installing non-metallic cable through holes in wood framing members, it's important to protect the cable from abrasion. NEC Section 300.4d requires that cables passing through holes in wood framing members be protected by bushings, grommets, or other approved means. These protective devices prevent the cable from rubbing against the sharp edges of the hull, which can damage the insulation and create a potential electrical hazard. Using appropriate cable protection ensures the longevity and safety of the electrical installation. Another key consideration is protecting non-metallic cable from physical damage during and after installation. NEC Section 300.4 requires that cables be protected from physical damage by raceways, guards, or other approved means. In areas where cables are exposed to physical damage, such as in unfinished basements or garages, they should be run in conduit or protected by metal or plastic guards. Protecting cables from physical damage prevents them from being cut, crushed, or otherwise damaged, which can lead to electrical hazards. When splicing non-metallic cable conductors, it's important to use approved methods and materials. NEC Section 110.14 requires that splices be made in approved junction boxes or enclosures using connectors listed for the purpose. Splices should be mechanically and electrically sound, and they should be insulated to prevent short circuits and ground faults. Proper splicing techniques ensure that electrical connections are reliable and safe. One must also consider the proper use of cable staples. Cable staples are used to secure non-metallic cable to wood framing members. It's important to use the correct size and type of staple for the cable being installed, and to drive the staple straight and flush with the wood surface. Staples should not be overdriven, which can damage the cable insulation. Proper staple installation ensures that cables are securely supported and protected from physical damage. When working with non-metallic cable, it's important to follow all applicable safety precautions. Always to energize circuits before working on them, and use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards associated with electricity, and take steps to minimize the risk of electric shock, arc flash, and other electrical injuries. Following safety precautions ensures that electrical work is performed safely and efficiently. When installing non-metallic cable in damp or wet locations, it's important to use cable and fittings that are listed for wet locations. NEC Section 300.6 requires that electrical equipment and wiring installed in damp or wet locations be suitable for the environment. Cables listed for wet locations are designed to withstand moisture and corrosion, and they are less likely to fail in damp or wet conditions. Using appropriate cable and fittings ensures that electrical installations in damp or wet locations are safe and reliable. When installing non-metallic cable in thermal insulation, it's important to follow the requirements of NEC Section 334.80. This section restricts the ampacity of non-metallic cable when it is installed in thermal insulation to prevent overheating. The ampacity of the cable must be reduced to reflect the higher ambient temperature within the insulation. Following the requirements of NEC Section 334.80 ensures that cables installed in thermal insulation are properly sized and protected from overheating. Proper planning is essential for successful non-metallic cable installations. Before starting any electrical work, it's important to plan the layout of the wiring, determine the size and type of cable needed, and identify any potential obstacles or challenges. Planning the installation in advance helps to minimize errors, reduce waste, and ensure that the project is completed safely and efficiently. Understanding the National Electrical Code is crucial for safe and compliant electrical installations. The NEC provides comprehensive guidelines for all aspects of electrical work, including wiring methods, overcurrent protection, grounding, and equipment installation. Staying up to date on the latest edition of the NEC and understanding its requirements is essential for all electricians and electrical contractors. In summary, installing non-metallic cable requires a combination of established industry practices and adherence to the National Electrical Code. By understanding the reasoning behind these practices and following the code requirements, electricians can ensure that residential electrical systems are safe, reliable, and compliant. From determining ampacity and providing overcurrent protection to grounding and box fill calculations, every aspect of the installation must be carefully considered. Furthermore, cable routing, protection from physical damage, splicing techniques, and the proper use of cable staples all contribute to the overall quality and safety of the installation. By prioritizing safety, staying informed about code updates, and following best practices, electricians can ensure that residential electrical systems meet the highest standards of quality and reliability. Remember to always energize circuits before working on them, use appropriate personal protective equipment, and be aware of the potential hazards associated with electricity. With proper planning, knowledge, and attention to detail, non-metallic cable installations can be completed safely and efficiently, providing homeowners with safe and reliable electrical power for years to come. It's also important to consider future needs when planning electrical installations. Adding extra circuits or capacity during the initial installation can save time and money in the long run, especially if the homeowner plans to add appliances, electronics, or other electrical devices in the future. Planning for future needs ensures that the electrical system can accommodate the homeowner's evolving power requirements. Education and training are essential for staying current with the latest electrical codes, technologies, and best practices. Electricians should participate in continuing education courses, attend industry events, and read trade publications to stay informed about new developments in the field. Investing in education and training enhances electrician skills, knowledge, and professionalism, allowing them to provide the highest quality service to their customers. Communication is also key to successful electrical installations. Electricians should communicate clearly and effectively with homeowners, builders, and other tradespeople to ensure that everyone is on the same page. Open communication helps to prevent misunderstandings, resolve conflicts, and ensure that the project is completed to the homeowner's satisfaction. Documentation is another important aspect of electrical work. Electricians should keep accurate records of all work performed, including wiring diagrams, circuit schedules, and test results. Proper documentation provides a valuable reference for future maintenance, repairs, and upgrades, and it can also be helpful in resolving any disputes or issues that may arise. Professionalism is essential for building trust and credibility with customers. Electricians should conduct themselves in a professional manner at all times, demonstrating respect, integrity, and a commitment to excellence. Providing prompt, courteous, and reliable service helps to build long-term relationships with customers and generate repeat business. In addition to technical skills and knowledge, electricians also need strong problem-solving skills. Electrical systems can be complex and challenging, and electricians often encounter unexpected problems or issues during installations and repairs. Being able to diagnose problems quickly and effectively, and to develop creative solutions is essential for providing quality service to customers. Finally, electricians should take pride in their work and strive to provide the highest quality service possible. Electrical work is a critical trade that directly impacts the safety and well-being of homeowners. By taking pride in their work and adhering to the highest standards of quality, electricians can ensure that residential electrical systems are safe, reliable, and built to last.